So let's talk briefly about decision report number one. The first thing that you need to do for the marketing project is figure out how to understand your data. And the data that you get from your teams comes out of a small number of relatively small-sized test markets. They're small in relation to the potential size of the total national market for your product. There's 150 million consumers in the country that might buy your product, 150 million national market. But each of these test markets is considerably smaller. So if I take test market number one, for example, it's only about 3.9 million customers. So this is test market number one. And inside of test market number one, the finding that your marketing team came up with is that if we set a price point of $332.95 per unit, this is dollars per unit. So maybe, I don't know, maybe I'm marketing I have an iPad in my hand, so let me just use iPad for an example. Right now, the base model iPad is retailing for somewhere around $300 to $350 in the Apple Store. So maybe let's say that these are tablets or something like that. And so I would go into this test market and say, would you buy this particular tablet for $332.95 unit price? And by asking that question, I find out that in that test market, we would get a total of 17,000 sales, 17,618 units of sales sold. And so what that does is it creates the all-important relationship in marketing between price and quantity, right? The quantity that we can sell, generally in marketing, depends upon the price that we ask people to pay for it. And what do you think happens if I ask for a higher price? What's going to happen to the quantity? It goes down, right. There's generally fewer people that are willing to buy the higher the price for something, right? And so there's a relationship. One of them has a causal, or at least correlational, impact on the other. And so our first task in this project is to figure out what is the nature of that relationship. How do we quantify it? How does price that we charge relate specifically to the quantity that we can sell at that price? So we want that relationship, but we don't want that relationship just to exist in one of these small test markets or another, because we've got marketing data, in this example at least, from 5 different test markets. Right? I've got maybe market number 2 over here, where there's 2.29, let's say 2.3 million people in test market number 2. And in that test market, we were trying to charge a higher price, $346.95. And as we expected, when we try to charge that higher price, the quantity that we can sell ends up going down, 9,700, 9,721, right? We want to know not just about these test markets individually, but we want to know what each of those test markets tells us about the big picture. So our first task in the project is to scale up the information that we learn about each of the test markets. We want to know what it tells us about the full national market. Not just if I ask these people how many sales I'll get at $332, how many would I sell? I want to somehow predict what happens if I ask everybody in the 150 million national market how many I'm going to sell at that price point. So what's the arithmetic? What's the calculation that we need to do in order to scale up this amount of yearly sales in my small test market up to the predicted number of yearly sales in my entire national market? This is exactly the same arithmetic as you do when you scale up a cookie recipe from feeding 5 people to feeding 15 people. What do you have to do to the size of the ingredients if we go from 5 people to 15 people? Multiply them by 3. Same kind of reasoning happens here. We want to know not just what these 3.9 million people are going to do if we try to charge them $332. We want to know what all 150 million people in the national market will do if we try to charge them $332. So if I want to answer the question, how many sales in my national market of 150 million what arithmetic should I do here? 2-step process. The first one is figure out how much larger is the national market than each of the test markets, right? It's like how much larger is my group of 15 people eating cookies compared to the 5 people in the recipe, right? So that's the first step, is to do that division. 150 million divided by my 3.9 million. And we can use let's use the full precision of this number, 3,896, 100. And I suppose then I should write out 150 million. So this number, once we compute it, is going to tell me how much bigger my national market is compared to my test market. And we could even interpret this number as a percentage if we wanted to. Get this number, approximately 38.5, and what this says is that the national market is 38.5 times as large as market number 1. Right? So even though test market number 1 had a lot of people in it, 3.9 million, the total national market has 38.5 times as many people as that test market does. So that's, in context, then what that ratio tells us. And that was the first step in the process, is just figure out how much larger the national market is. Now, how do I turn that number into the total sales that we expect in that national market? What's the second step? We need to scale up the total sales by that amount. Here the assumption, remember, is that the test market was representative of the national market, which means that if I have 38.5 times more people, 38.5 times as many people in the national market, I'm going to sell 38.5 times as many product in the national market. So my total sales then, we expect to be 38.5 times the sales in that test market. So multiply that by 17,618. And somebody with a calculator want to get that for me real quick? Great. So we multiply that out. We get a number 678,294. And so we infer then that if we were to ask the national market to sustain a price, a unit price of $332.95, we would expect that the national market would support a total sales quantity of 678,000. 678,294. And it's important that each of these tests markets is turned into the national market data before we try to compare them one against another. Because if the test markets have different sizes, these yearly sales cannot all be interpreted one against another, right? It doesn't, for example, necessarily mean that if I'm selling fewer units in test market 2 compared to test market 3, that that's going to hold in the national market for these two prices, because the markets had different sizes. So the other thing that this calculation does is it puts all of the test marketing data onto the same foundation, right? It scales it all up to what we might think of as a common denominator, using the national market as a common denominator for all of our sales numbers. So that when we do this process for all of our data points, we're going to get numbers that we can actually compare with one another. And the two variables that this sets up for us that are going to power our entire project are in these last two columns here. Well, not the last two, the column there and the column here. Price, which we'll denote with a P. This is measured in dollars per unit. This is how much that we want to charge for our product when we sell it on the national market. And then secondly, in the last column here, national sales, we're going to call that Q. And the last thing I want to say about these variables is that because the numbers that we end up needing to use for Q tend to be fairly large, like this is 678,294, for convenience sake, what we like to do is to scale this down so that instead of Q measuring the number of units that are sold, I actually want to change this, just for making the arithmetic easier, I want to change this so that its units are not units, but are thousands of units. And so to do that, I would just divide this number by 1,000. Right? So that instead of Q being 678,294, it would be 678.294. And that'll be my first data point. P is 332.95, Q is 678.294. I do that for all 5 of my test markets, and what I get is a relationship on the national market between the total quantity that I can sell and the price that I would charge in order to sell that many. So let's take a moment and do that calculation. We did it for just one data point just now. Let's do it for all of them in Excel. So these are going to be, again, my national sales in thousands. And that's going to be that's going to be Q. And price per unit is what we're going to call P. In Excel, how I would get Excel to do this calculation without me having to do everything by hand is I would just use a formula. Hit the equal sign to start your formula. And then we'll just go back and recreate what exactly were the calculations that we did in order to get what we got. The first thing we did was figure out how much larger the national market was compared to the test market. To do that, we just divided the 150 million, so click to make a cell reference there at D10. We then divided that D10 by the size of the test market. That's in C14, so I'll just click on C14. That gave me my 38.5 that we had in the previous calculation. Then we wanted to multiply, so I'll just hit a multiplication symbol there. Multiply that by the number of sales that we had in that test market. So there I'll click on E14 to get me that cell reference. Excel is nice, it color codes everything, so I can see exactly what I've done. I've divided this by that, and then multiplied by that. And then the last thing that we did was to scale it down to units of thousands by dividing by 1,000. Hopefully, that calculation, that formula, should give me the same result in this cell as what we just got doing the calculation out by hand. Sure enough, there it is, 678.29. And of course, the beauty about using Excel formulas is that then we don't have to redo that calculation a bunch of times. We can just copy this formula down to get the rest of the column. You can do that using a copy-paste command, or my favorite is you can just grab onto this little fill handle in the lower right-hand corner in Excel and just pull it down. And by pulling it down, it automatically, it should have automatically copied the formula. Does anybody that has Excel experience know why that didn't work? Yeah, we have to anchor, exactly. This 150 million up here needs to be fixed into place so that when we drag the formula down, that reference doesn't drag down because we didn't want that reference to drag down. So how do we anchor that reference, which this was a reference to D10? How do we make that an absolute reference? Dollar sign. In front of what? In between the D and the number? Yeah. In fact, that's as much as we need. We could have also put another dollar sign in front of the D, but it actually doesn't matter that this is a column absolute reference. It really just matters that it's a row absolute reference. We really just want the row number not to change. So if I put that dollar sign there, and then I do that again, now we see the behavior that we expect. So there's how we can do all those calculations just with a spreadsheet. Just get all of your national sales information up against your price per unit. And these Q's and these P's are going to be what power the whole rest of the project, because this is all the data that we got out of the test markets for the demand for our product.